Good morning, friends. I welcome you to my channel Educational Information for All. I request you to subscribe my channel and hit the bell icon for new video notification. Now we discuss regarding adsorption thermodynamics. The effect of temperature on the adsorption of metal was studied at different temperatures with fixed initial metal ion concentration, adsorbent dosage, and initial pH. Adsorption is temperature dependent. In general, the temperature dependence is associated with their thermodynamic parameters, normally change in enthalpy of adsorption, symbol delta H naught, change in entropy of adsorption, symbol delta S naught, and change in Gibbs free energy, symbol delta G naught. According to the concept of thermodynamics, in an isolated system where the energy cannot be gained or lost, the entropy change is the driving force for sorption. The value of delta G naught, delta H naught, and delta S naught can be calculated by using the following equations that we can say want half equation. Delta G naught equal to minus R T ln Kd. Kd you can say QE divided by C. Here R is the universal gas constant. We can value will be 8.314 joule per mole Kelvin. Temperature T is the temperature in Kelvin. Kd is the equilibrium constant. Also you can say the distribution coefficient. QE the unit will be milligram per liter. The equilibrium concentrations for solute on the adsorbent. C unit will be milligram per liter, the equilibrium adsorption concentration for solute, also you can say adsorbate in the solution. The enthalpy delta H naught and entropy delta S naught parameters were estimated from the following equation. Delta G naught equal to delta H naught minus T delta S naught. So you can write ln Kd equal to delta S naught divided by R minus delta H naught by RT. We can draw a graph ln Kd versus 1 by T. Here from this we can find out slope and intercept. Slope is minus delta H naught by R and intercept delta S naught by R. The plot of ln Kd as a function of 1 by T yields a straight line from which delta H naught and delta S naught were calculated from the slope and intercept respectively. Here delta G, to understand the delta G naught is unit kilojoule per mole, also we can write calories per mole, Gibbs free energy. The negative value of delta G naught indicates that the adsorption is spontaneous and feasible. The positive value of delta G naught indicates that the adsorption is non-spontaneous. You can see some points. The degree of spontaneity of the reaction increases with increasing temperature. The negative value of delta G naught decreases with an increase in temperature, indicating that the spontaneous nature of the adsorption is inversely proportional to the temperature. Delta G naught negative value increase with temperature, indicating the feasibility and spontaneity of the adsorption process. The range of value between 0 to 20 kilojoule per mole further confirms that the adsorption process is a physisorption process. Delta H naught unit will be kilojoule per mole, also calories per mole, enthalpy. The positive value of delta H naught indicates that the adsorption is endothermic. The negative value of delta H naught indicates that the adsorption is exothermic. Positive means endothermic, negative is exothermic. Endothermic reaction, the explanation you can see here, the increase in temperature would increase the rate of diffusion of the adsorbate species across the external boundary layer as well as inside the pores of the adsorbent particle. This might be due to the decrease in the viscosity of the solution. Furthermore, an increase in removal percentage of the sorbents at higher temperature might be due to the amplification of pore size distribution. It was depicted also that the active surface sites increased proportionally with the increase in temperature. Next, exothermic reaction. The adsorption uptake decreases with increase in solution temperature. This might due to the successive desorption of adsorbate species in the equilibrium mixture. This is due to the deterioration of weak van der Waals forces between the active sites on the activated sorbent and the adsorbate species. It has also been reported uh, earlier that increase in temperature might decrease the uptake as physical bonding between the adsorbate and the active sites of the adsorbent is destabilized. However, it is essential not to go beyond the optimum temperature limit because the increase in temperature causes an algorithm algomerization process and beyond the critical temperature. Desorption takes place spontaneously leading to a reduced rate of sorption with contact time. It was suggested by previous researchers that the increase in removal percentage with increase in temperature is due to the increase in kinetic forces. The mobility of the sorbate or adsorbate species or metal ion inside the sorbent matrix. The highest limiting in the change of enthalpy for fission is usually less than 80 kJ per mole, whereas chemabsorption is between 80 to 420 kJ per mole. The positive value of the delta H naught obtained show that the process is endothermic in nature and its range values 2.1 to 20.9 kJ per mole implies that the process is physically controlled. Next we see delta S naught joule per mole Kelvin entropy. Positive delta S naught values indicates that increasing randomness at the solid bar liquid interface during adsorption increase with increase in initial metal ion concentration. Positive values delta S naught indicates that the adsorption is irreversible and negative reversible process. Positive delta S naught values indicates that increased randomness at the solid solution interface with some structural changes on the adsorbent's surface during the sorption process. The negative value of delta S naught correspond to the decrease in the degree of freedom of the adsorbed species. The adsorbed water molecules, which are displaced by the adsorbate species, gain more transitional energy than is lost by adsorbate ions, thus allowing the prevalence of randomness in the system. The enhancement of adsorption at higher temperature may be attributed to the enlargement pore size and or activation of adsorbent surface. Positive delta S naught values indicates that there was an increase in disorder in the solid solution interface, indicating that the entropy was the most predominant factor for the adsorption spontaneity of their residues. Positive values of delta S naught confirmed the increased randomness at the solid-solute interface during the adsorption process, which shows the solution system tends towards stability when the adsorption of heavy metal on the surface of the adsorbent occurred according to the second law of thermodynamics. Overall, it could be concluded that the thermodynamic characteristics of the absorption system vary with the type of adsorbent and adsorbent being used as they possessed different physical and chemical characteristics with influence of the absorption mechanism. There is a no consistent trend with which could be predicted on the thermodynamic behavior of the adsorption process and the actual factor for this phenomenon. You can see some spontaneous reactions. The process occurs in naturally, there is no external energy required. One example, NaOH plus HCl is NaCl plus H2O. 1 more CuSO4 plus Zn is given ZnSO4 plus Cu. Burning of coal or hydrocarbons. So we can given like that initiated energy, we can say non-spontaneous reaction is required external energy. N2 plus O2 is 2NO. Here we can see enthalpy is delta S naught, temperature T, and entropy delta S naught. Delta G naught is a gift free energy. If delta G naught is less than 0, that is spontaneous reaction. If delta G is equal to 0, that is equilibrium. If delta G naught is greater than 0, that is non-spontaneous reaction. So given box, if delta S naught is greater than 0, then value will be positive. Then delta H naught is negative, less than 0, that is spontaneous. If delta S naught is greater than 0 positive and delta H naught is greater than 0 positive, then that is spontaneous at high temperature. If delta S naught less than 0 negative value and delta H naught less than 0 negative value, that is spontaneous at low temperature. If delta H naught is less than 0 negative value and delta H naught greater than 0 positive value, that is non-spontaneous. So one reaction written here, if ice is converted to water and if water then converted to ice. Here endothermic and exothermic are given. If temperature is greater than 0 degrees Celsius, spontaneous and high. If temperature is less than 0 degrees Celsius, spontaneous is low. So clearly I have written here, see, if delta H is positive, delta S is positive, temperature is high, delta H is negative, value obtained, that is spontaneous endothermic. If delta H is negative, delta S is negative, if temperature is low, delta G naught is negative, that is spontaneous exothermic reaction. If delta H is negative, delta S is positive, T is temperature is all, anything high or low. If delta E is negative and G is negative, that is spontaneous exothermic reaction. If delta H is positive, delta S is negative, and temperature is anything, and delta G is positive, then it is non-spontaneous endothermic reaction. Thank you.